Hello my dear children. Today we are going to learn the construction of ray diagrams for a convex lens. A ray diagram determines the position and the characteristics of image formed by a lens. To draw the ray diagram, you should follow the following procedure. First, draw a straight line across the paper which is the principal axis. Choose a point O on the principal axis as the optical center. Now, mark 2 points on the principal axis equidistant from O, which is the first and second focal point. Depending on your convenience, it can be either 2 cm or 3 cm away from O. Mark double the distance as 2f1 and 2f2. That means if you take 2 cm from the mark O as focal point, then 2f must be 4 cm away from O. Finally, mark the optical plane and the lens in such a way that the principal section of the lens should be on the optical plane. The rays actually suffers refraction 2 times, that is, when it enters and emerges the lens. But since we are considering thin lens and it is difficult to show the refraction 2 times, we will draw the refraction only once, which will be from the optical plane. Now, let's see the rules that we should follow while drawing the ray diagrams of a convex lens. Generally, for constructing ray diagrams, we use 3 principal rays. The first ray is a ray of light incident parallel to the principal axis of the lens. This ray, after refraction, passes through the second focus f2. The second ray is the ray of light incident at the optical center O of the lens, which passes undeviated through the lens. Finally, the ray of light passing through the first focus f1 emerges parallel to the principal axis after refraction. These are the 3 rays we consider for drawing the ray diagrams of a convex lens. So let's start with our ray diagram. The first position is when the object is at infinity. Here we can see the object in our plane. Then how will we draw the image? So here our assumption is when object is at infinity, the rays coming from object are parallel rays. So we can have parallel rays from the object, and we know the parallel rays meet at the principal focus. So the image will be formed at the second principal focus or second focal point. Since the rays are actually meeting at the principal focus, the image formed will be real, inverted and highly diminished. In this manner, a convex lens is used either as a burning glass or a camera lens to take the image of a distant object. The next position is when the object is beyond 2f1. In this position, the object distance is more than the radius of curvature, and we can see an object on the plane of the lens. This is the object. The bottom of the object is on the principal axis and the top of the object is above the principal axis. We know we are using at least 2 rays to draw the ray diagram. So keep one thing in your mind, that the first ray should always be the ray parallel to the principal axis, and the second ray should be the ray which passes through the optical center. If the question is asked, to draw the ray diagram for 3 rays only, you should think about the ray which coming through first focal point. So, here the rays incident parallel to the principal axis, and as we all know, it should pass through the second focal point. And the ray which passes through the optical center passes undeviated. Now, if we look, we can see that these two refracted rays actually crosses each other and it meets at a point in between F2 and 2F2. Now, we started rays from top of the object, that is, the rays are incident from the top of the object, so that the meeting position will going to be the top of the image. Now the bottom part was on the principal axis and the object is vertical to the principal axis, so we should keep the bottom of the image also at the principal axis and make it vertical to the principal axis. Now we will get an image upside down, that is inverted. Now we can conclude that the location of the image is in between F2 and 2F2 and the nature of the image is real, inverted and diminished. A convex lens is used in this manner as a camera lens when the object is not very far is to be photographed. Let's move to the next diagram, that is when the object is at 2F1. So again we take a ray parallel to the principal axis from the top of the object and it will pass through the second focal point and the second ray through the optical center passes undeviated. The meeting point of the rays will give the top of the object. Now we can draw the image perpendicular to the principal axis and here A dash B dash is the image. The image is formed at 2F2 on the other side of the lens and it is real, inverted and of the same size as the object. In this manner, a convex lens is used in terrestrial telescope for erecting the inverted image formed by the objective lens. The next position is when the object is in between F1 and 2F1. Here also we take a ray parallel to the principal axis which passes through the second focal point after refraction and the second ray through the optical center passes undeviated. We will get the image somewhere beyond 2F2. And in this case, the nature of the image will be real, inverted and magnified. In this manner, a convex lens is used in cinema or slide projectors. Here, the magnified image is obtained on a screen placed at a large distance from the other side of the lens. Now let's see the ray diagram when the object is at F1. The first ray is parallel to the principal axis after refraction passed through the second focal point and the second ray passes through the optical center, goes undeviated. Now we can see two parallel rays which will not meet anywhere on the plane. So, if the object is at F1, the rays will not meet after refraction, so we will not get any image. We will get it as two parallel rays. So, by our mathematical concept that the parallel rays meet at infinity, we consider the image formed at infinity. The nature of the image is real, inverted and highly magnified. In this manner, a convex lens is used in the collimator of a spectrometer to obtain a parallel beam of light by placing the source of light at the focus of convex lens. Now let's look at the final location, that is, the object is somewhere in between the optic center and first focal point f1. Here also, as in the previous ray diagrams, the first ray, which is parallel to the principal axis, passes through the second focal point after refraction, and the second ray through the optical center passes undeviated. Here we can see two refracting rays which is diverging each other. So if we extend the rays backward, we can see the rays meet on the same side of the object and behind the object. That is, the nature of the image is virtual, erect and upright, and is magnified or bigger than the object. In this manner, a convex lens is used as a reading glass to form a magnified virtual image of a tiny object. Hope you all draw all the ray diagrams in your notebook by pausing the videos after each ray diagrams. I hope all the image formation is clear to you now. Thank you and have a nice day.